Gak ada suaranya. We have problem. Pak Dendi, saya nggak dengar suara.
Iya, Prof. Ini masih belum masuk, Prof, dari ruang 1.
Nah, it seems to be speaking.
Assalamualaikum warahmatullahi wabarakatuh. First of all, let's offer our worship and praise to the Almighty God who has given us health and strength. Today there will be a difference from today. Parallel room, if you want to join or parallel room, I will opening first presentation. Continue to the second presentation, and after we finish the second presentation, we'll announce the best participant of the session 2021. Then I will read this presenter for the first session. Room there will be for the second room there will be Anggoro Nadi the Professor Widi Pratikto. For the fourth room
Bisa mulai Pak Dendi.
Mr. Muhammad Akhtur Razi. For the second session will be Professor Daniel M. Rashid. For the second room there will be Mr. Firdaus. For the third room there will be Mr. Ahmad Firdaus. And for the fourth room there will be Mr. Yoyo. Without lingering any longer, first before we start today, after it's time to put all the moderators. So all moderators, the time.
Okay, good morning, ladies and gentlemen. Thank you, Prof. Widi. Welcome back to the second day of Isoceen 2021. Over the last 9 years, Isoceen has strong networks of researchers, industry, and professionals of related fields. The Isoceen theme of this year is promoting ocean coastal engineering innovation and collaboration for sustainable development. I'm Dendi Satrio as the moderator of Room 3. Today, there will be two speakers with the presentation first, then continue to the Q&A session. Okay, let's start the session. The first speaker is Prof. Widi Agus Pratikto from ITS Indonesia. I will share his curriculum vitae first. Prof. Widi Agus Pratikto have a lot of experience, such as Executive Director at Coral Triangle Initiative on Coral Reef, and member of National Ocean Council, senior consultant in GIS conducting assessment of SSME, chairperson of Asia Pacific Fishery Commission, and the others. Many experience. And he has doctoral philosophy in Department of Civil Engineering from North Carolina State University, and master degree in Department of Civil Engineering at George Washington University, and bachelor engineering from IT. Ladies and gentlemen, today Prof. Widi will be present about managing marine debris in coastal and ocean waters. Prof. Widi, please, time is yours.
Thank you very much, Dr. Dendi, for having me to be speaker this morning. This supposed to be laboratory chair for having the material, but since Professor Mukhtasar as well having another seminar, so I will be representing the what we call it laboratory for environment and energy. So I think Pak Dendi, the material should be I will control or somebody else will control.
If needed, I can help, Prof.
Okay, can please help me by having the material that being sent to you?
Yes.
You have already?
I will open it first.
Okay. Thank you very much. Okay. Okay. Thank you very much. So the title will be Managing Marine Debris in members, myself, Pak Mukhtasar, Professor Mukhtasar, Dr. Hasan, and Dr. Sadiq. Next, please. Okay, so since I will be having conflicting time, so I will propose to have the 30-minute presentation that will be including question and answer. So hopefully I will be finished up for 20 minutes or 23 minutes. So 7 minutes or 10 minutes will be having a question and answer. Having the marine debris in terms of pollution, Indonesia is number 2. So in the second after the China, we have to deal with, especially the way how we manage the debris. We call it also sampah rumah tangga, but then flowing through river, coming up to the sea. So awareness for this will be part of the activities. Next, please. Everybody having coffee already. So I think we will be moving next slide, please. Okay. So when we are dealing with the area of, we call it coastland and waters, we will be dealing with Act 27, 2007, Undang-Undang Coastal and Small Island Act. That will be that was established in 2007, but then in 2014 it was updated to Act number 1, but might be 90% same. We will be dealing as well. We call it with Act 32, Ocean Act, and recently we have to deal especially Act number 23, because all the matters relating to coastline and waters and ocean being regulated or re-regulated, all the matters then from the central government and the provincial. So there is no such power in Kabupaten Kota. So this is the thing that we have to face the situation. One thing, the matters, all the debris mostly under the activities in the Kabupaten Kota or in the county, district, and city, but the regulation should be going to province under the Bapeda, Sekda, and Kelautan Perikanan. So this is the matter that I would like to discuss. Next. This is just overview that Indonesia is very big country. So when we see that as big as United States, the matter Indonesia consists of waters, but United States mainland. Of course, we are not comparing in terms of size, the power of something like that. I would like to show you the imaginary view that we need, what to call it, knowledge, we need power, we need coordination in managing the whole Indonesia system, which consists of 34 provinces, consists of, this is should be corrected. I think now it's about 419 kabupaten kota and 98 kota, sorry, county, 19 county and 98 city. Yeah. Next. So we have before comparing to United States. Now we are comparing in the Europe. So we stretch over from Great Britain up to, this is Iran, you know, the place here is Iran. So I think all people in Indonesia have to be aware that the situation is complicated, in large size. So I think we have to be serious in managing marine matters. Next. So I think we are dealing with, I will be review shortly because a lot of matter that we might have better to discuss rather than what you call it, explaining this matter, you know. So when we talk about coastal zone management, later on we call it CSM, we basically rely on what we call it Law 27. So Law 27 mentioning that all the matters up to 12 mile is regulated under the coast, we call it coastal. Next. So this is the thing that we are dealing with. So this is what we call it shoreline, the what we call it the waters and the land is over here and 12 mile there, and we call it one kecamatan. I don't know the exactly when we call with the British or American standard, because county actually like kabupaten, but kecamatan is less than county. Kecamatan usually one kabupaten consists of might be 6 or 8 kecamatan. Next. So this is another view that we are dealing with the area. Next. So this is the spatial delineation. So you might have the definition. We call it rezim Undang-Undang 26. This is matters of dealing with tata ruang, tata ruang in land. But when we are talking about regime 27, we call it zonasi, So this is the regime 26. This is assignment to us, everybody, expert, KKP, and PU, PU is the Public Works Ministry. So we have to work together how to make all the matters under Undang-Undang 26 and 27 will be at the same language. Otherwise, for example, now the scale of UU 27 and 26 is a bit different. So if we have a picture from the airplane or from satellite, so we have to work out very hard. So this is the thing that we have a homework, how to deal with this kind of scaling. Next. So this is the legal framework. This is just part of the thing that we have been discussing at the beginning. We are mentioning that Law 27 revised in 2014 become the Law 1 2014. So this is the thing that actually we learn from the United States and other country, especially Canada. So when I was a DG in Ministry of Marine Affairs, we were traveling to Hawaii, to North Carolina, to Maryland and other places, as well as to Canada, to have fact. We are bringing the member of parliament. So I think this is very important one, because we have to work together in getting Act 27 at that time. So it's quite long to have the process of Undang-Undang 27. Next. So this is the legal framework. Next, please. This is the arrangement. So when we have coastal small island, we have governmental regulation, what kind of PP. So I think this is the detail of the matters under the law 27. So we have president decree, this is the president decree, ministerial decree, and this is the local government. So this is the distribution of arrangement of the decree or regulation under the government, under the presidential decree, under the ministerial as well as local government. Okay, next. This is comparison. In 2014, there was a changing of what you call it, definition or articulation or something like that. So when we call it integrated coastal management, then we incorporate Undang-Undang 32, Undang-Undang Kelautan. So we merge, we call it integrated coastal ocean management. Next. This is the matter that actually we have to elaborate or discuss this session. We know that all matters problem actually, especially in Java, because Java is very populated island. So, and the arrangement of public work, pasar, sampah, or debris, especially through kabupaten kota. But now the regulation, and on top of that, the permission, the permit should be getting from the province. So how we solve or how to make this kind of arrangement? working. This is the thing that we have a challenge to work. So since I was in the DG at the time, I tried to figure out the way how we make arrangement, Dinas Kelautan Perikanan, Bapeda, Sekda in the province. We communicate with kabupaten such as Probolinggo, Gresik, and others that I know of, how to work together as exercise to make the regulation handling the debris will be working out. So ICOM application at land area of coastal, targeted capacity building. So this is the thing that we have to communicate. ICOM model kabupaten city level. Apply pollution marine debris control program, strengthening institution. So a lot of things that we have to communicate between province as well as kabupaten kota. So this is actually the matter of business. I'm glad that in the participant, I think you might develop such as NGO or after graduating from UNERO, ITS or Brawijaya, for example, to make arrangement facilitating this matter. At the beginning, might be we have to have like startup, we have to have or capital, but later on many grant available in the international. For example, last year I was invited by the Norwegian government through ASEAN. They will pledge for Indonesia and ASEAN $15 million. This kind of thing. This is one source. Usually, beside the Norwegian, Denmark, United States also concerned about the marine debris, especially because Indonesia is producing fish. So if the water or seawater is not quite good, then the quality of fish will be in danger. Next. Next part. Okay. Relevant act. So this is the, we correlate, we try to correlate between this kind of activity. Actually, restate what was in the previous slide. Next. This is marine pollution. We will figure out what is or what are the marine pollution. Next. Oh, see, this is accident in 89. It was in part of United States. We call it Exxon Valdez in the area of Alaska. Next. This is this similar one. Next. Marine ecosystem, including animal, will be in danger. So we can see that, we can see that when oil, that's 89, by having that accident, Exxon Valdez, then starting the ship should have double wall, before only one wall, but then after accident, American Bureau of Shipping endorsed with 2 wall. Then that will be spread over all country having the dual for the tanker. So spread the oil slick movement through weather, by wind or by wave, something like that, then come up to the animal or whoever living in the sea. Next. Marine litters or debris. Next. So this is the statistic of the rank. That's why I can mention that Indonesia is number 2. The first one, China. Next. This is China number 1, number 2, Indonesia. So I think we have to take concern, not only concern, but we have to take action. Hopefully that Dinas Kelautan Perikanan Jawa Timur also presenting in this session, because I think we cannot deal with nationwide if every province just hanging into central government. So I think we have to reverse. We have to mobilize every province to have all together. Then we'll be having Indonesia as entity dealing with marine debris. Next. Impact of marine pollution. Next. So major effect of oil spill. We will be having problem with local industry, of course, human health, marine ecosystem, vegetation, mangrove, all will be in danger because of the oil spill. You know, we call it as well man-made disaster. You know, next. So I don't know whether you are all of you aware or not, but we can see that inside of the fish, sometimes we may find what we call it is microplastic. You know? So you have to check the inside of the fish. Or you might have experience or might be examination in the laboratory to do that. So this is the thing that oil spill is very dangerous in the food when we talk, especially in Maluku, in Papua, that fish will be the important part of the food security, you know, because mostly they are eating the protein from the sea, and also not only in Java might be more many options to have the protein. Next one. So this is marine mammal, reptile, bird will be in endangered species situation, you know, because oil. So this is oil slick. Next. Impact of marine debris. Next. So we can see that this is in Surabaya, you know, impact of marine debris. So actually we have economic loss. For example, if we develop the marine ecotourism, then there is no, or there will be no people attracted to visit this area, you know, habitat damage. So I think when we are dealing, but now it's getting better. We know that in the area Sukolilo, in the area of Kenjeran, you may find so many things like this, you know. But now it's getting better, even though still not good. Vessel damage and navigation hazard. So when we have like plastic or something, we have small boat or ship going to propeller, that will be in danger. And as well as human health. Some we might take the waters from ocean to desalinate and make the water for the city. But in the case Surabaya, we will be having from the river rather than from the sea. But in Saudi, we are taking the water from the sea. You know? So this is the situation that we have to consider, that marine debris is part the situation that we have to dealing with to remove those kind of hazard and to manage the way how distribution or compilation of the marine debris coming up. Next. This is situation that starting up with canal cleanup. So you can see that some previous year like this, and now it's like that. The problem will be how we have maintenance mechanism, you know. So how can we keep it like that? This can be solved like this if there is a project, one. Second one, there will be like working together, interministerial, with NGO, with support from might be USAID or Nigeria, Sweden or Norwegian, something like that, for act of beach cleanup. You know. But we have to maintain that every single week, we have to maintain the situation is like this. This is the thing that we are very important, that we are managing the marine debris. Next. This is the activities of marine debris. So once a year or twice a year is fine, but we cannot afford the situation that every month we will be having beach cleanup activities. This is not good, you know, because we should have rely on the mechanism since we have dinas, we have Bapeda, we have university and some other thing. Next. So we interview, we picture the situation because I think I was making study the impact of Pelabuhan Teluk Lamo, you know, in between Surabaya and Gresik. So we have the situation like that. So the relationship between province and kabupaten in all matters related to marine should be solved, should be putting in the agenda. So they will be having a situation that the Dinas Kelautan Perikanan in the Kabupaten Kota having access to talk with the Kepala Dinas in province. The situation is not yet to that situation. So I think we have to work out, especially from university, especially myself, to help the solving the situation. Next, the role of province. This is actually Bapeda, Dinas Kelautan, Mitra Bahari. I think we will see the diagram Mitra Bahari and university, as well as the way how Kabupaten Kota part. We do having also HAPI, ya, Himpunan Ahli Pengelola Pesisir. Next. We almost finish ya Pak, waktunya ya. Halo Pak Dendi.
Yes, Professor.
2 minutes
You
to
still
go.
have, yeah, 2 minutes.
How many minutes?
2 minutes.
2 minutes, okay. So I will be making quick. So this is related to Perda. This is program Mitra Bahari that actually, you mean next slide, please. This is university. This is Ministry of Marine Affairs. This is the Dinas Kelautan Perikanan in Jawa Timur, NGO, something like that. So actually, under Act 27 is already there. The thing is that now ministry or dinas hesitate to do that. So I will conclude the conclusion, Pak. Please go to conclusion. Okay. So before the conclusion, please one step before conclusion. Yeah. So there are several steps to make awareness of the community. One, aware. Second, understand, accept, behavior change, education, and partnering by outreach. So we have to make arrangement community aware about marine debris. They are not putting all the debris in the river, or that will be good if we are separate plastic and non-plastic or something like that. So next to the conclusion, please. So need to empower, improve the community participation, strengthening coordination, and need center of excellence. So I think we need example in 34 province, for example, Jawa Timur, should be reflecting the champion of the excellence. Sakira itu Pak Dendi, I think that will all, the remaining time might be 1 minute or so. Please, if you do have any question. So this is the big challenge for Indonesia actually, but I should have advocated this matter in the bigger picture, even though I've been mentioning to Sulawesi Utara, for example, in Jakarta. But the thing is, sampah is not too important to us, because not directly having.
Halo, Profesor. Halo, Prof. Widi. Prof. Widi, you still join with us? Hello, Prof. Widi. Okay, maybe Prof. Widi have a problem with connection. We waiting for him first, some minutes. I'm sorry that maybe Prof. Widi have a problem with his connection. Prof. Widi have very excellent and interesting presentation about marine debris. And I see in the column chat that there is several interesting questions too from for Prof. Widi. Hopefully he can join as soon as possible. Okay, thank you, Prof. Widi, for joining us again. I'm sorry for the participant or audience that waiting because Prof. Widi has internet connection. Prof. Widi, please turn on your microphone first.
Okay, thank you.
There is several interesting questions, Prof. Widi, from the audience. The first is from Pak Yuda Miasto. I think he is from DKP, if I don't. Yes,
Okay, Pak
DKP
Dendi,
Jatim.
Pak Dendi, please give my handphone and email If necessary, then I will follow up after the session.
Okay, maybe I can read some of the question, Prof.
Okay.
Widi. Question number 1 from Pak Yuda, DKP Jatim. With your experience as a DG in MMEF regarding the marine debris, what are the best solution for this matter? Have you some information how to develop countries such as America to handle marine debris?
Okay.
And the last, please give some advice for me, especially for government institution, to handle this matter. As you know, it's become a classic problem, especially in East Java province.
Okay. Ada lagi? Selain Pak Yuda, ada lagi? Is there any other?
There is some, Prof. The next question is from Pak Ari. Oh, this is in the case in Surabaya, Prof. The handling of waste in Kenjeran Beach may need to involve other cities Surabaya.
Okay.
But the trash come from the sea, said one official. Is it possible that the garbage or the trash from another city was carried away by the ocean currents, Prof? So not only from the city or near the coastal zone.
Okay. Is there any other?
And this is another question from Pak Sunan. One of the important thing about marine pollution caused by mining, especially gold, because of mercury. Oh, just information, bro. Just additional information.
Okay.
Indonesia is number 2 on food waste and loss in the world after Saudi Arabia.
Okay. Okay. Thank you very much all. I will try the best, but please do connect to my WhatsApp number as well as email. I will be getting in touch with you. First, Pak Yuda, under the new regulation Act number 23, I think what we can do is that we are setting like a timeline for communication or something through Mitra Bahari, because Mitra Bahari actually when I was DG, it was there and it was in the good shape. You know, Pak Daniel Rosid was the chair of PMB Jawa Timur. Pak Mutasor at the time was the secretary. So the engagement is very good because many of engagement targeted activities can be held. But lesson learned now is changing. Undang-Undang 23 in place. You know, so one permission, for example, when establishing the Pelabuhan Teluk Lamong, the site of zonation was decided by the provincial. But then the impact, Gresik and some other area will be having impact. I was part of engaging activity, bridging the port karena di bawah Pelindo 3 and DKP Gresik. So we arrange how to make like education and training for people that was dipindahkan ya, di replace. Jadi itu ada kompensasi dan sebagainya. Jadi waktu itu Pelindo 3 berkenan kita arrange ketemu dengan Pak Khairul. Meskipun saya belum ngecek ya apakah sudah terlaksana atau belum, tapi arrangement was there. Jadi memang kita harus aktif. Nah, Pak Yuda, kondisi KKP sekarang beda dengan dulu ya. Dulu kita agresif tanda petik mencari dana untuk daerah-daerah. Jadi misalkan daerah Miangas misalkan. Indomie, the price Indomie 15,000, you know. So we get the money from DPR for Pelni, and then we have MOU with Pelni, and Pelni bringing doctor, nurse, Indomie to the island and remote area. So this is the thing that we have. Now the situation is different. I cannot tell, you know, but this is the thing that I will talk with you, Pak Yuda, if we are getting in the Zoom meeting different. USA is strong because in the state North Carolina, state of Maryland, most of the case supporting by the university. So this is the thing that I would like to have permission to you to ask Ibu Dr. Bu Maya ya, Bu Kepala Dinas untuk having such communication with me or with us, with several friends from university, how we help her to manage the situation. The second one, Pak Arif. When I was DG, every year there was 2-time discussion with Australia. And Australia is always blaming us, you know, this is your garbage, this is your debris. So this is the thing that we have to have traceability regarding the debris, but it is difficult. So what we can do is that, for example, debris from Kenjeran might be coming from Gresik or might be from Lamongan, because you know the sea, the flowing sea is going to Selat Bali and then flow in the southern part, go to Darwin, you know. So these plastic matters mostly come up to Darwin. If you go to Darwin, so many plastic from, they call it from Indonesia, but sometimes it's from China, you know, not from Indonesia, from China, from Malaysia, from Vietnam. So this is the thing that we have to work together, we have to communicate and to solve the problem. Pak Sunan, I think we have learned from Petty, you know, pertambangan tanpa izin in Manado. So I think dealing with nickel, titanium, especially, I think we have to be frank. I think we know that many of those kind of industry, I heard that due to the permission, for example, dari Pak Luhut atau Pak Menteri BUMN or something like that. Then we have to have picture or photo, fact, and communicate with them. This is the thing that very important. Discussing through WhatsApp, blaming is not good, you know, it's not solving. So we have to have like fact, just like Petty, you know, Petty, I was going to Sulawesi Utara, and then we are visiting Sulawesi Utara governor, and we are talking with MMAF because I was DG. So it's easier to solve whenever people engage is participating to solve the matter. But again, Pak Dendi, I will open up to facilitate, to help if the case needed. So you may, all of you may send to WhatsApp or to what you call it, email. You know, I'm sorry that because 8:15 I have to teach. You know, because now it's very hard to get some other time, replacing time. You know, especially for tahun pertama, mahasiswa tahun pertama, we have to have good care because otherwise then they will be not good student. That's why I'm promised that 9:15 I will entering the room for class and teaching them for introduction to ocean engineering class.
Okay.
I thank you much all, and hopefully that we'll be able to meet each other again and having some other discussion.
Thank you, Professor. But may we take a photo first, Professor,
sure,
for
sure,
documentation?
Sure.
Please, everyone, open your camera. We want to take a picture. There is 2 slides here. I will count 1, 2, 3. Okay, for the next slide. 1, 2, 3. Okay. Thank you very much, Prof. Widi.
Ya, sorry tadi buru-buru tadi sudah pakai Isoceen yang pertama. Tapi yang kedua ini mungkin karena sudden death ya. Kita di-expel terus. Oke,
No problem,
and I'll be leaving soon. Thank you.
Thank you very much, Prof. Widi.
Thank you.
Okay, very nice discussion for the first session. Ladies and gentlemen, we can now we can continue to the next speaker. There is another interesting topic too from the next speaker. The second speaker is Dr. Ahmad Mukhlis Firdaus from ITB Indonesia. Dr. Ahmad, are you ready?
Yes, please.
We meet again, Dr. Mukhlis.
Yeah, we meet again.
Uh, I will introduce yourself first to the audience. Dr. Ahmad Mukhlis Firdaus is from ITB. He has a lot of experience too, including involved in many research projects on marine renewable energy and involved in many port development design projects such as feasibility study or master plan study. And he has a educational background, doctoral degree in University of Oxford, and master and bachelor degree in Institute Teknologi Bandung. Oke, Pak Mukhlis, Dr. Mukhlis, please, the time is yours.
Okay, can I share my screen now? Oh, okay. Have you seen my screen?
Yes, clearly.
Okay, yeah. Good morning. Thank you, Dr. Dendi Satrio, for the introductions. My topic today will be about is more mathematical. Apologies for this, but as I thought, this will be academic discussion. So it would be nice to have discussion on this more mathematical background on it. So my topic will be review on tidal energy calculations, the approximations and limitations. Okay, this is my outline presentation. So we're going to talk about the current practice of tidal power calculations. We're going to talk about the Lanchester-Betz limits, what is the Lanchester-Betz limits, tidal power in a channel, and then the Hawes-Wheeler models, and the Froude limits, and exceeding Betz limits, and power capping, and thrust capping, and side interactions. Okay, the first one is, this is the, if you look for many projects or for many publications in this field, they are putting these kind of equations on their calculations. They just put that the 0.4, 0.5 times rho times the velocity, the undisturbed velocity cube, multiplied by the area of the turbine, the frontal area of the turbine, and calculate with the efficiency of the turbine. That's the common practice that we would see in many resource assessment in Indonesia. But this is the problem. If you calculate something like this, you assume that there is no interactions between flow and the turbines. So this is the first picture that you see in the screen is like, so this is what happens if you use these equations. This is your assumptions, but this is what actually happens. The flow is changed when you put turbine, where you introduce turbine in the streamline. So how we can deal with this mathematically? We can learn from what we call it as in the wind turbines. We call it as the Lanchester-Betz limits. So this is how it's happened. So it's like this. So turbines, it can be determined by what we call it as a wake coefficients. So we calculate the thrust first. The thrust is the resistant force that applied by the turbine to the flow. So that makes the flow is slightly decreasing in terms of flow in the downstream of the turbine. So this is the thrust equations like this. The power is calculated like this. And we know that the CT and CP is correlate to the what we call it as wake coefficients. The wake coefficient is this alpha 4 here. What is alpha 4? Alpha 4 is the fractions of the flow speeds behind the turbines compared to the flow speeds in the front of the turbines. So when the flow is still undisturbed. So this is what we call it as the wake coefficients, and we know the turbine velocity coefficients as from the wake coefficients. I'm not going to derive this mathematically. I'm not going to destroy your thrills on doing the calculation by yourself. And then if you look at for these assumptions, and you find out what the maximum, if you use the derivations and use all the mathematical expression on it, you will find the maximum CP that can be obtained mathematically is will be 16/27. And that's what we going to ask. Okay, what is this wake coefficient in terms of turbine in reality? So the turbine itself has what we call is the pitch angle. So if you change the pitch angle, you will see that the flow behind the turbine will change as well. Okay, and this one has happened to show that there is a limit on the turbine's extractions, on the power extractions from the turbines, and this limits is been found by Lancaster, Betts, and it's the other author is Joukowsky. So usually this limit for some people this limits is referred to Lancaster, Betts, and Joukowsky limits. They are independently found these limits actually. Okay, and then if you look that for different wake coefficients, so you change the wake coefficients, that you will have this Betts limits as the peak of the CP, and then but this is what happens. It's in the reality. Okay, if you aim for the maximum power on this in this graph, that means you comprehend that the thrust is pretty high. It's 0.5 from the maximum thrust from the undisturbed kinetic flux, which just means it's a lot for the turbine. So that means you have to design your turbine is very strong, which means it's quite expensive. And then the other issues will be the turbines should be able to the other issues will be it makes the capex is become more and more expensive because your superstructures become more expensive. So sometimes for turbine developer, it's better to go to these limits, and then we can go much lower thrust, which means that the structure, the superstructure, the blade itself is not required as strong as if we have just around 1% higher from the maximum Betts limits here. Okay, so this is the issues on doing this one. But the question is can we use that equations on the tidal turbine, since we adopt that equation from the wind turbine? And this one is as we got it from the Garrett and Cummins in 2005. If you look at their publications for the Garrett and Cummins, they show that the turbines can interact with the tidal dynamic itself. So they use what we call it as 1D models here, using this one's the assumption of the Navier-Stokes with the 1D approach, and then they calculate the turbine as the two factors is here. This one is they put bed friction and turbine resistance here, and then they try to calculate the maximum power based on the change of the turbine's resistance in the tidal. And they found that in certain conditions, the turbine will interact to the tidal dynamic. So this is, for example, so when the bed friction is high, the turbine is no longer, no longer comprehend. The equation shows that the turbine resistance is no longer become predominant effects here. But when the bed friction, which is the most of the case of the turbine in the narrow channels, the turbine resistance change the tidal dynamic behavior here based on their finding here. Okay, and then they published in 2007, and then they show that okay, we cannot use directly the equation for the wind turbine because it's very different. So they introduced the new way to calculate the wake, the turbine velocity coefficients. They introduced what we call it as blockage ratio. What is blockage ratio? Blockage ratio is the fractions between the turbine's frontal area and the cross-sectional area. If you have the axial flow turbines like this web area, that means that this is circular area, the sum of the circular area over the cross-sectional area. If you have cross flow, that means you will have rectangular cross-sectional area, the sum of all the electronal area here over the cross-sectional area is the blockage ratio. What they found is like, okay, this is the batch limits. They exceed the batch limits. They exceed the batch limits. Is the flow from the turbines, if you put at the certain blockage ratio, will be higher than the blockage than the batch limits. Okay, what is the condition for this is like, you need to have a turbine at least 10% of your turbine's frontal area occupies the entire cross section of the channel. Only 10%. By 10%, you can reach the capping power. The CP here almost is 80% from the natural flux. This is high. If you can achieve 0.4, you will have this. If you even exceed the natural kinetic flux from this one. So, but there is a drawbacks from this equation, from this Garrett commit. So I'm talking this mathematically. It's not in the reality. So it's the mathematically. If you see that the mathematical expressions on their equations, they found that it's the maximum power is corresponds to the 1 minus blockage ratio power by -2 here. So what it means? If you have blockage ratio almost 1, although I have to say it is almost impossible to have a blockage ratio almost 1, but this mathematical expression show that the power goes to infinity, which is not acceptable for some people in mathematical speaking here. And this is Holsby in 2008. Actually, this is my supervisor. Introduced, okay, maybe we should encounter the deformations of the surface water. So they put the surface water parameter in their equations, and so they have to introduce what they call it as beta 4. Beta 4 is the bypass flow coefficient, which is, since the turbines in the side of the turbines where they are without the turbines will experience the increasing flow in that certain area, they will have this kind of beta 4. So if you include the beta 4 in the equations, you will find these equations. You have to consider the Froude number here, where the Froude number will be velocity divided by the depth of the channels, the root square of the depth of channel, and then the gravity. And then we will have something like this. The Froude numbers show that the power is increased at the certain blockage ratio. So we will have this advantage at the high blockage ratio. So but the consequence is the same. The CT is also increased, which means the turbine will encounter the very strong forces in this one. Okay, but this is what I found on my research actually. If you look for these equations, you try a lot of equations, combinations in equations, in the equations, and mathematically speaking, you will have the equations that return to imaginary results. So I drew these limits, what we call it as Holsby valence limits here, where the equation, the solution is unavailable. Although in reality, this solution is still available. And then we try to find out why this happened. So so I try to do these combinations, and then I found out maybe it's correspondent to because in the beginning we assume using the Navier-Stokes, which is the Navier-Stokes has problem with the smoothness. If we can solve this problem, we will win the Millennium Prize, which is, so you will get the $1 million US dollar if you can solve this problem mathematically. So you encounter the Navier-Stokes smoothness problems immediately once you try to see the assumptions and spacing the assumptions in the beginning and everything. So this is the other limitations of the calculations. Okay, but that equations is still powerful to explains the resources in water. As we have I think this one is already encountered already introduced more physics in the equations. I think this is the best limits. So Holsby-Wheeler models is suggest that the CP can have much higher the CP from the best limits, and so we know that the reductions in far downstream, the pressure head downstream to the energy extractions and additional energy losses in Q due to the flow remixings. So we know that's this based on the mathematical expressions. So we try to look for this. Okay, let's see that's the turbine. So because the Holsby-Wheeler models look the turbines. So this is the number of turbines. They just look the turbines as uniformity or one single turbine, although this one. And we could try, okay, wait, let's see the turbine as a single entity like this. We see the turbine becomes from its own diameter, the distance between turbine and everything. And then we this is we use the separation flow of scales, use the coupled mass momentum energy conservation on both class scales, and then we find we have to introduce what we call it a blockage, local blockage ratio and global blockage ratio. Global blockage ratio is the same definition that I already introduced before, and this one the local blockage is the blockage that's introduced by any for every single turbine like this. And then what we found is like the turbines is interact to each other as well. And then we find the increasing CP when the turbines is closely to each other. As you see, this is if the turbine is have in a distance to each other, the CP only 0.69, but when it's getting close to each other, is 0.74. Experimentally, numerically, this results. Sorry, and then we can trust these results. So what is the impact to the rotor design? So when we talk about the blockage ratio, that's mean we have to put the very strong rotor design, which means the rotor design is getting bigger. Since if you look for the wind turbine is still what we called in the industry is this unblocked rotor, which is very slender typical rotor in this condition. As you see here, as the unblocked conditions here, the performance is high, but that means you need the higher wake coefficient as well. But we have another consequences as well. The thrust is also high, and the turbine spinning much faster, which means we still need to consider the cavitations problems on the turbines. The solution is not been found yet, but I think this will be interesting for us if we know that's what happened with the turbines, how we can reduce the turbines rotations. In return, we still have high torque on the spinning turbines. Okay, and then I move on to the power capping and thrust capping. So on the turbines extractions, on the tidal power extractions, what we have is actually all we cannot use. We don't want to use all the power that produced by naturally by the turbines, because as we know that the tidal cycles will be have a spring cycles only have the maximum speed only twice a month, or sometimes maybe once every 2 weeks. And then it will be uneconomical if we exploit all of the power. So what we going to do is like we introduce rated power. So we will going to have something like this, and then the thrust will reduce as well at the same time if you do the feathering blade here. So this is the power situation. So if the red one here, as you see in the screen, is like this one is after you implement the capping strategy, and this is the thrust that you will have after you implement the power capping strategy. At the same time, we also can limit the turbine operations by the thrust, because let's say the thrust, we don't want the turbine has this too much thrust, and then but limiting the thrust that walk to the turbine to the blades means you also limit the power production. So this is what happens if you do the thrust capping. So this is the power capping and thrust capping situations. Okay. In turbines industry, we know a metric, what we call it as capacity factor. The capacity factor is the average power after the capping is divided by the power capping or power cut out here. And this is how we calculate it. And we get the capacity factor from this. Okay, and let's see if we implement directly the capacity factor. The capacity factor is the most common thing that we have in the turbine. Apologies, I think. Oh, sorry, I don't know why. Sorry, I accidentally closed the slide, I think. Okay, let's so where we were, so here we are. Okay, so the capacity, so the type of the slide type across the globe is like this. As you see here, our in most of the flopped area of the tidal energy industrial is semi-diurnal, while if you see in Indonesia, it is dominated by a mixed diurnal and diurnal side. We do have this by semi-diurnal here. It's more complicated in each side, in its straits. I mean, so we are. I think this will be another discussion. But if you see this NASA maps is showing that we have mostly is the mixed diurnal. For you who not familiar with this, semi-diurnal have two tidal cycles in a day, while diurnal only one tidal cycle in a day. The mixed diurnal has in between. So mixed diurnal has more complicated pattern of the tidal cycles. Okay, this is what I found. I tried to solve this equation. So we call it the asymmetric problems. Solving the asymmetric problems in the tidal harmonic equation. So we found we can distinguish the equation, the cycles, the tidal pattern into three groups here. We have something like this, which is the most common one. This is like the symmetric one, and then the asymmetric one. And then if you look at the capacity factor for each case, you will find that at the mixed diurnal, the very asymmetric one, you'll find the capacity factor in this location is tend to be low, and vice versa. If you aim for a high capacity factor, that means you have to reduce your maximum power to 45%. So it's a lot. You have to sacrifice a lot of energy if you have the same approach. Therefore, we introduce new metric. So we cannot rely solely on the capacity factor. So we introduced what we call it the power pack factor, the thrust factor, which is correspond with the reductions of the power and the reductions of thrust after you implement the capping limit. Okay, and okay, I continues to this one. Another case, what I found is like, okay, this is side-side interactions. Draper in 2004, Draper at 2014 found that each sides will interact to each other. As you see here, this is the case in Penmountford in the UK. You will find that the flow, the power productions will increase when three sides, which is BCD here, is is exploited together. So when is BCD exploited, the B here, so it's like B if it's a when they do it single, just single sites here, they only want 122 megawatts. When they include B, C, and D here, they will for the site B will get 320 here. It's increased, is double, is more than double from the individual sites exploitation. You will see the same trends for other sites here. You see D has more advantage than other sites when they exploited together. This is, you see the other combination B and C, B and D, C and D also have the same one. And at English channels, Coles et al. 2017 also find the same pattern for the English channel. Okay, I did the same analysis for the Lombok Strait here. So you can see this is from my publication 2019. So this is the Lombok. So A, B, C is Lombok Strait. So this is the power calculations, and then I use, as you see that from the pattern, I use more constituent than the previous authors. They use the only M2 because their location is semi-diurnal, which is less complicated than us. So I need to use the 13 constituent in order to give a clear picture of these locations. What happened is, like, it's very unique. At low blockage ratio, you will find decreasing trend when it's exploited together. When A, B, C exploited together, the flow, the power at, but only at C, not at other location. At other location has, we can say that this is almost has no effect. The increasing effect, you can find it at a high blockage ratio, but at the C here, we still have this low I mean the decreasing trend as well. So it's quite the opposite as we saw in the Penmanford and English channels in Indonesian sites here. So this is one is interesting. We have to carefully plan for Indonesia because sometimes if you have another competitor work in this one, you already exploit this one, and then sometimes and then in the future you have competitors exploit the Badung Straits. That's when you will have encounters losing the power productions. This is the other issues in Indonesia. And then we try to explain how it's happened. So I look for the flow field change in this location. So as you see here, when we see the flow field here is not just interact in this particular straits as well only, but it's also interact to the alas here. You can imagine that this is how large the impact of this one. When you see this only A and B, the diverted channel flow only occur on the C strait here. That's what we find here on this particular site. If you look on the big picture, the whole regions interact to each other. So this is a very unique case for Indonesia. So I think this is one and another big research questions of this in terms of the development of the theory, development of the resource assessment method in these locations. I think that's all from me. Thank you very much. I'm looking for your comment and your questions in the education in this discussions sections. I hand over you back, Dr. Dendi.
Okay, thank you very much, Dr. Mukhlis. Very nice and interesting presentation, especially about ocean energy. Okay, ladies and gentlemen, now we enter the Q&A session. I will remind the participant or audience who want to discuss or asking a question. Please give the question via chat box, or you can raise hand and open your mic, not a problem. Then we will select and deliver to the speakers. Okay, for the participant who want to discuss or asking, please chat in the column box, or you can raise hand and open your mic. Okay, here there is one question, Dr. Ahmad.
Yes.
What is the difference between in the Europe and Indonesia? Because in your presentation, the effect is different, or in the contrary. In the Europe channel, it's positive effect, but in Indonesia, it become lower if we
Okay.
place some turbines over channel.
Yes. Yes. That's what I found as well. So my first guess is because we have more complicated tidal pattern, and this one is also interact with the global current. Indonesian true flow goes through this site, the particular site. It's in Lombok Strait. So once you give obstructions to the flow will react as it is. This naturally will react. That's what's the second guess. Um, that's why we need to understand for example, the Laratuka is actually exactly the same as in the Europe. So you don't have to worry about the straits. So it depends on the locations, which means okay, taking forward from that questions like we will have different tapping strategies, which means the way we determine the capacity of the turbines, the capacity of the generator, when the feathering blade and everything will be different. Although even though we use the same turbines as what's commercially available in the market at the moment. I think that's all, Dr. Dandi.
Okay, thank you, Dr. Ahmad Mukhlis. Is there any question from the audience? Okay, here there is a question from Mr. Farid P. Bhakti. Dr. Ahmad, when you consider the free surface deformation effect, does other free surface phenomena, in example wave, wind, generated current, and etc., has any effect on the calculation too?
We not yet put that effect to the equations because it's already complicated. As you know, we have to encounter the smoothness when we put the surface deformations of in the equations, which means we have to solve the millennium problems in order to solve that that anomaly in the equations. So once we solve these equations, we wonder the 1 million price first, and then we can encounter the change of the externals surface deformations due to the wave, due to the wind and everything. Yeah, maybe that's even more complicated to the equations again. Thank you, Dr. Farid.
Okay. Okay, thank you, Dr. Farid, for the question. Actually, I have same like wondering about same question from Dr. Farid, because like in Indonesia several channels is not deep enough. And how about the influence from boundary layer that form in the seabed, Dr. Ahmad? Is there also influence in the performance?
What we found is like so it depends. So sometimes it depends on your support structure. So once that we encounter this like the vortex the vortex shading behind the turbines will interact with the bed frictions from the seabeds. So if we have a shallow water, we have first thing, what one advantage we will have is like we can have the blockage, the higher blockage ratio due to that shallow water. Okay, it's easy to get the high blockage, local blockage or global blockage. And but the second one is will be we need to be careful about the because the bed frictions creates another turbulence underneath the on the seabed layer. So it will be interact with the vortex with the in the behind of the turbines. We don't know what is the effect to the turbines fatigue life and everything, but we know that for sure that might be increase the turbine performance. But you know, when we have this kind of advantage, the disadvantage will comes in the other sides. For example, or the thrust will increase as well.
Okay, because I have read in Magellan, we need several distance from the seabed for our turbine.
That's to avoid the sedimentation or any debris issues underneath from the turbine. So it's hit the blades. The blades will become yeah, the lifespan of the blades will be decreased because of that.
And also the
So that's why
conductive effect.
we in contact. Yes.
Okay, thank you. There is another question from Pak Novan. In city calculation by Holsby that considering water surface deformation, any effect on the vertical distance between turbine plates adds to the seabed, scoring of seabed and seabed surface type maybe. I think it's quite similar with what asking
Yeah.
for.
Yes. I think similar to the Dr. Dandy questions. Like at the moment, as I mentioned before, the equations only we make assumptions. We simplified the problem. That's what we did in these equations. So so that's why in order to prove that equation is correct, because it's correct, it's just, using the simplifications, we did the experimental measurements. We did the CFD simulations, and we found that it is the simplifications is correct. We can use that simplification. But if your question is like regarding and contact the distance and everything is no at the moment, because we assume the flow is uniform from the upstream of the turbines. So I think that's yeah. I hope that's answer your questions.
Okay, thank you, Dr. Ahmad, for your response. I think it's already clear. And there is still another one question. Maybe this is the last question. In your slide or presentation offer, we see that all of your work is in the mathematical background. Have you read or see that there is like from the physical background, maybe there is an experiment that conducting several turbines in the channel on in the towing tank or in the flume tank and prove that the blockage effect can improve the coefficient performance.
Yeah,
What
I
do
think
you think, Dr. Ahmad?
yes, I think I already mentioned before. So we did in Oxford we did. So actually it's not by me. It's by the PhD students actually. So we did the experimental investigation as well. So we did using the porosities assumptions. So we use the exactly porosities and we use the thrust as to check the thrust of each porosity, and we found the same. Is consistent with the equation with the mathematical, and then we also did the actual turbines in the flow tank as well. So we change the contra rotations or contra or uh, is the same directions of the rotations. We still have the same, but the thing that we don't encounter is like the equations that I showed you before doesn't have any we did the to simplify the effect on turbine to turbines interactions. So that's why if you look at the slides as I show that the turbine is actually slightly increased when they put too close to each other like this. So we did like this in numerically. We did this one since experimentally. We used the forest disk turbine, and we also used the actual turbines actually. I hope that answered the questions.
Okay, thank you. Thank you, Dr. Ahmad. It's very clear. Thank you very much, Dr. Ahmad Mukhlis. Maybe before we close your session, we can take a picture first. So for the audience, please turn on your camera. We want to take a picture for documentation in this session. Please, the audience, turn on your camera. Okay, I will count. 1, 2, 3. Next slide. 1, 2, 3. Okay, thank you. Thank you very much. We give applause again to our speakers. Thank you,
Okay,
Dr.
thank you
Ahmad
very much,
Mukhlis.
Dr. Dendi. Thank you all.
Ladies and gentlemen, finally we reach at the end of the parallel session. Thank you very much for our speaker, Prof. Widi Pratikto and Dr. Ahmad Mukhlis. But I will inform to the participant before closing the session, please stay at this room because there is a best announcement. We will choose one of the best participant from this room, and after this we will announce who is the winner. Then will be continue with closing statement by the chairman of the Isoceen 2021 from Prof. Daniel M. Rosid. So please wait in this room until the agenda is done. So after this, I return it back to the MC. Thank you very much.
Becoming an ocean engineering student. What will we get? How important the future of ocean engineer to Indonesia? Indonesia has enormous potential in ocean research as we have more than 3 million kilometers square. Of course, the professionals in marine development are needed. As we get busier in the ocean, we need to provide adequate infrastructure and equipment to make sure everything goes well. So, come with me and explore ocean engineering together. Welcome to the Ocean Engineering Department, Institute Teknologi 10 November. As the pioneer of ocean engineering education in Indonesia, we provide the best education to shape the graduate in the field of construction, maintenance, and the development of onshore and offshore structures. The future of ocean relies on its sustainability that we learn about ocean renewable energy and environment. Balancing the development of technology, we also learn about marine digitalization. Established in 1983, Ocean Engineering is part of the Marine Engineering Faculty, Institut Teknologi 10 November.
Merupakan sekretaris program studi teknik kelautan yang didirikan tahun 1983 yang pertama kali, kemudian mengawal sampai menjadi jurusan teknik kelautan yang di-establish atau didirikan tahun 1985. Kemudian bersama-sama ITB kita menerima program bantuan dari Dikti melalui support Bank Dunia atau World Bank 17 menjadi program US1 Ocean Engineering.
The education quality has been accredited A by Indonesian Accreditation Board for Engineering Education and National Accreditation Board for Higher Education. Our vision is to be a higher education institution of ocean engineering in international level that become a reference in Southeast Asia. Our missions are organizing higher education in ocean engineering to the younger generation, conducting innovative and qualified research of ocean engineering science, also responsive to the development of community problem solving in national and global scope, to provide science-based ocean engineering services for government, industry, and society, ethically manage the department effective, efficient, transparent, and accountable. We offer bachelor's degree and master's degree in ocean engineering, bachelor's degree in offshore engineering, and doctoral degree in ocean engineering science. Our department is supported by professional educators, including 4 professors, 17 doctors, and 6 magisters to reach our vision and mission. To support the research and education development, there are 6 laboratories in ocean engineering. So, let's see the activities in each laboratory. This laboratory is expected to be able in research and development of structure and material such as bending tests, tensile tests, and many more. The main facility in this laboratory is a towing tank that can be used for measurement of ship resistance, seakeeping testing, and maneuvering on a limited scale. This laboratory is also equipped with the computational fluid dynamics. Laboratory of Coastal and Marine Environment with all supporting facilities, this laboratory is ready to provide services in the use and management of coastal and marine resources in the field of research, surveys, and technical consulting. Center of Marine Environment, Marine Energy, and Coastal Engineering Development. This laboratory is equipped with a flume tank, waves, current, and wind generator. This computational laboratory serves to support practicums from several subjects, including computational